Welcome to the Open School, a school where teachers all around the world help students all around the world. Yes, you remember this bulb, right? This exercise, we had a bulb with 50 watts. And the first question was, okay, describe how the energy is transformed by the light bulb. It's transformed from electrical energy to light energy. So I'm finding another pen. So electrical energy, oops, what am I writing? Energy to light energy. And every second, there's 50 joules per second of light, which is provided by the bulb. So if it is lit for 8 hours per day every day, how much energy was transformed into light energy in a week? So that you would take 50 joules multiplied by the number of seconds that correspond to this period. So 8 hours. And how many seconds in 1 hour? 3,600. And we did this for 7 days. So if I calculate this, I think, if I remember, it's 10 megajoules by 8, by 7, by 3,600. Yes, 10.08 million joules, so megajoules. Okay. So we know that this bulb is sending light around it. Let's do a little thought experiment. Let's draw the bulb and put it in a balloon, a huge balloon which is 1 meter of radius. Let's build this balloon with a sheet of white paper. So the light emits in all directions, right? And will reach the surface of the balloon. This is a sphere, right? Around the bulb of radius 1 meter. So we are going to try to find out how much energy is received by the cloth of the balloon that is around the bulb. Well, it's going to be, every second, it's going to be 50 joules, right? So what would be the intensity received by the cloth? So just imagine I have 1 meter square here on this balloon around the bulb. How much energy would he receive? Well, the energy received by this 1 meter square is going to be the power per unit area. So we need to find out the area of the balloon. So this is a bit of geometry. So let's do a little bit of geometry to remind us of these formulas. So I'm going on the main thing. Yeah. If I have a circle, right, with a radius r. Now the perimeter, which will be the length, like this, the perimeter will be 2 pi r, right? So that's in meters, it's a length. I'm going to put length. Length in meters. The area of the disk. So if I want to find out the area here, the area of the disk will be pi r squared. You know all this stuff. So that's an area in meters squared. That's for a circle. But now let's think in 3D. Let's think about a sphere, like a balloon, right? So I'm going to draw a sphere here. And when I draw a sphere, oops, I can't see all the camera. Voilà. When I draw a sphere, I actually draw stuff in front like this. I can show you it in 3 dimensions. So the radius of my sphere would be r, But you could find it like this, like this, like this, you know? So what would be, well, the perimeter of my sphere? So I go around the balloon, right? And I go around the balloon. I don't have a balloon here. It would be nice if I had a balloon. Do I have a balloon here? I don't. Unfortunately, I don't have a balloon in my office. Well, so you have to imagine the balloon, and you go around the balloon, like if you were a little ant going around the balloon. So the perimeter of the sphere is also 2 pi r, because you just described a circle. What about the surface of the sphere? It's going to be bigger than the surface of the disk, right? Whoop. Well, the area of the sphere will be 4 pi r squared, 4 times bigger than the area of the disk. And you can, so this is a length in meters, and this is an area in meters squared. But for a sphere, we can also define a volume, right? You calculate the volume of the sphere. And the volume of the sphere, but we won't need this, but I just tell you, because we're there, the volume of the sphere will be 4/3 of pi r cubed. So this is a volume in a meter cube. Voilà, so what formula we need, us, for our intensity is this one. Let's go back to the idea of the bulb in the sphere. I'm going to keep my sphere here. So here I have my bulb. And it's has got 100 watt of power. It sends light all around my sphere. It's inside the balloon. So when I look at the balloon, I see the light on the surface of the balloon. So what will be the intensity here? The intensity will be the power received by the whole sphere, because it's the same as that of the lamp, divided by the area of the sphere. Because the intensity is power divided by area. And the area of the sphere is 4 pi r squared. I sometimes say area, sometimes surface. It has the same meaning. Yeah? Please know that. Okay, so let's do an example. Please read the exercise, try to figure it out, pause the video, ask questions to your teacher, and then we will meet again to see the answers and more explanations. Don't hesitate to ask questions on his Skype account, and if I can answer them, I will.